Hello, dear children. I hope you are all fine and doing good. So far, we have been discussing about electricity and some basic concepts related to electricity. Now, before moving on to the topic, I would like to tell you something about an inspiring invention, that is electric bulb. The man behind this inspiring invention is Thomas Alva Edison. Do you know which is the material that is used as the filament of the bulb? It is tungsten. Tungsten is used to make the filament of the bulb. I've told you it is an inspiring invention. It is because tungsten was not the material which was primarily used by Edison. He has conducted thousands of several other experiments with various other materials, and finally he found that tungsten was the best among them. So he has taken a lot of effort in bringing out the electric bulb into this world. I hope that you will also make the maximum out of your time during this period. Now, let's move to our topic. Our topic for today is Ohm's law. George Simon Ohm was a German physicist, and he has conducted an experiment, and finally he formulated the Ohm's law, which is named after him. Okay, now let's see what his experiment or his study was. Here you can see a electric circuit, and there are several components in this circuit like a cell, key, ammeter, voltmeter, and a nichrome wire. So these are the components of the circuit. Now here you know that ammeter is a device. Ammeter is a device which is used to measure the current in the circuit, and voltmeter measures the potential difference across the conductor. Here nichrome wire is used as the conductor, and a voltmeter is connected across the wire so that it can measure the potential difference across the conductor, that is the nichrome wire. Okay, so from this you are going to measure two parameters. One is the potential difference as well as the current. Okay, ammeter reading will give you the current, and voltmeter reading will give you the potential difference. Okay, this is the tabular column you can see certain values like the potential difference, current, and V by I. So after measuring the potential difference and current, we have formulated or tabulated the values. Now first column you can see the serial number is given, and the second column you can see potential difference. Under that V is written, potential difference and its unit in bracket. Okay, similarly current and its unit, that is ampere, in bracket. And the last column we are dividing the potential difference by the current. Okay, the first reading was 0.5, and the second, and corresponding to that, the current reading was 0.2, and in the last column we have divided 0.5 by 0.2. Okay, and we have obtained 2.5. Similarly, the second reading obtained in the voltmeter was 1.125, and corresponding to that there was a reading in the ammeter, and the reading was 0.45. Now we are dividing 1.125 by 0.45, and we have obtained 2.5 as the result. Similarly, a third reading is also obtained. Now, analyzing the tabular column, can you see anything similar? We can see that the V by I values of all these readings are same. And also you can see that when you increase the potential difference, the current value is also increasing. First it was 0.2, then 0.45, then 0.54. That means the current value is also increasing as you increase the value of the potential difference. So there are two important things that you have to note from this experiment. That is, as the potential difference increases, current also increases. And also V by I is always a constant. These are the two things you have to keep in mind. After conducting his study, George Simon Ohm formulated the Ohm's law. From all these observations, he tried to derive the Ohm's law. Okay, now let's derive the Ohm's law. Now we have seen that as the potential difference increases, the current also increases. That is, that how can we mathematically express that? If one physical quantity increases and the other quantity also increases, we can write it as V proportional to I. That means as V increases, I also increases. And in order to remove this proportionality sign, we have to multiply I with a constant. So V is equal to a constant multiplied by I, that is the current. Now we can say that if you're taking I to the opposite side, what will happen? V by I is equal to a constant. And this constant is known as resistance and is denoted by the letter R. Okay. So we are deriving the Ohm's law mathematically, and we have given a name for the constant, and that constant is called as the resistance R of the conductor. And now we can write V is equal to, V by I is equal to R. That is, V is equal to, take the I to the other side, we'll get V is equal to I into R. So this equation is known as Ohm's law, or the mathematical form of Ohm's law. V is equal to I into R. The potential difference is equal to current multiplied by resistance. So how can you state Ohm's law? Ohm's law states that the potential difference applied across the ends of a conductor is directly proportional to the current flowing through the conductor, provided that the temperature remains the same. Okay, that is the statement of Ohm's law, and this is the mathematical form of Ohm's law. That is, V is equal to I into R, or V is equal to IR. This is the mathematical form of Ohm's law. So Ohm's law states that the potential difference across the ends of a conductor is directly proportional to the current, provided that the temperature remains the same. The temperature should be same. Okay. Now we are going to calculate the unit of resistance. We have told that we have removed the proportionality constant and added a value, or call the constant as resistance. Now we are going to find out the unit of R, or unit of resistance. From Ohm's law, we know that V is equal to I into R. V is equal to IR. So you have to keep R in one side and all other terms should be brought to the other side. R is equal to V by I. Okay. Now, in order to find the unit of R, you have to add the units of all other terms in this side. This side we have V and I. V is the potential difference and I is the current. So, unit of potential difference is volt and unit of current is ampere. So, we are going to add that, and that is V by A. V is the unit of potential difference and A is the unit of current, ampere. Okay. Now we have obtained the unit of R as volt per ampere. So volt per ampere is the unit of resistance. This unit, or this is also called as ohm. We know that Ohm formulated the Ohm's law. In order to give respect to the scientist, we are using Ohm as the unit of resistance. So SI unit of resistance is Ohm, OHM. It is denoted by the letter omega. Suppose you're stating that the resistance of a conductor is this much, then you can state it as the resistance of a conductor is 5 ohm. The resistance of the conductor is 6 ohm or 10 ohm, 1000 ohm, etc. So this symbol is used to denote ohm. Okay, this is a Greek letter which is omega. So in this class we have studied two things, that is Ohm's law, its statement as well as its mathematical form. I've shown you a tabular column and given you some values. So for the next class you have to draw an XY graph in which the voltage is taken in the y-axis and current in the x-axis. With those values, you have to draw the graph and study the shape of the graph. Here, as a conclusion, we can say that we have studied two things. Ohm's law. Ohm's law states that the potential difference across the ends of a conductor is directly proportional to the current flow in the circuit, provided that the temperature remains the same. And how can you write it mathematically? It is written as V is equal to I into R, or V is equal to IR, where I is the current, R is the resistance, and V is the potential difference. I hope you have understood. Thank you.